Alright, let's talk about partition equals subset sum. So given a empty array nums containing only positive integer, so find the array can be partitioned into two subsets, such that the sum of the element in both subsets is equal. So this is the array, and then you can partition to 1, 5, 5, and 11. So let's just start coding, and I'm going to use 2D array, and for every step I go through, right, I will memorize it. And this is called memorizing DP, or you can say memorizing recursion. So this is going to be boolean since we return boolean. So I'm going to say DP. So in, and I'm going to say in equal to num_length, and also I need to sum every element up in the array. So when I add everything up, right, if this number, if the sum is R, right, then you cannot divide into two subsets. This is because if a number is R, right, this is only be a one subset only. You cannot have two subsets. So for int nums sum will plus equal to num, and then if sum is mod 2 is not equal to 0, then you just return false. And then if that is true, right, if sum mod 2 is an even number, then you can actually divide into the half, divide your number into the half, and then when you initialize your DP, you can reduce a lot of memory, because when you cut into the half, right, you only need to know the maximum for the DP will be 11, not 22, right? So I would say sum will divide by 2 right now, and then initial my DP. So my DP boolean, the starting, the row will be n plus 1. You need to include the index 0, and the column will be sum plus 1, right? And this also includes the index 0, right? So later on I will just use my helper function. So can partition, and what do I need to pass? I need to pass the num. I don't need to pass DP. DP is global variable. I need to pass the current sum, and I also need to pass the index, which is starting from 0. Okay, so I need to initialize the helper function. So I'm going to say int sum int index. So if the sum is actually equal to 0, this is true, right? You don't need to worry about like if, because we need to reduce from this number to 0, right? And then if that is true, you just return true. So if the index is equal to the num_length equal, and also sum is less than 0, you just return false. This is all abound, and this is that you deduct too much, and this will be it, right? And also if the DP at index at sum is not null, which means we traverse already, so just return DP index sum. And the last one, the last return will be easy, so I'm going to say return. So you still have to initialize, you still have to assign your DP index and sum equal to something, right? And this is the last scenario you have to think about it. So you either move your index, one union right, or delete the nums, right? So if you want to delete 5, right, and you can actually just index plus 1 and then sum minus nums index. And if you don't want to delete it, for example, if you don't want to delete 11, right, then you can just move on your next index. You don't delete your nums index at this position, right? So this will be a little bit tricky, so let me just code it and you'll be able to understand it. So it's either nums. So this is, I want to delete this current value in this num, and sum will minus nums at index. And if I delete it, I need to move on to the next one. And also in this scenario, I don't want to use this value, but I still have to move on, right? So sum index plus 1, and this will be it. And let me just double check, and here we go. So I hope I don't make a mistake, and I do. Like KOE will be another scenario to talk about it, but in this case I'm not going to talk about it. So this will be a little bit, I would say it's pretty much like it's either you jump or you don't jump. But if you do jump, right, you want to know, like, you don't want to deduct your current value. But if you don't jump, right, you need to like deduct your current value and then move on. So this will be like the scenario you have to think about it. And let's just talk about the time and space complexity. For the space, this will be easy. You initialize your n times s. S represent the sum, and definitely you need to traverse n times s, the length of the nums array, and then the sum. So the final solution, I will just copy and paste my note. So this will be the solution. And if you feel helpful, subscribe, like if you want it, and then leave a comment if you have any question. And I will see you next time. Bye.